Okay, so this is the periodic table of the elements. Every element is represented, and every element has a name. So for instance, we have hydrogen. And hydrogen, we call it hydrogen, but we might as well have called it number one, the number one element. Notice it has the number one here. And for instance, helium, we could have also called the number 2 element. And lithium could have been called the number 3 element. So these elements are placed in the table in this order, in the order of their numbers. And these numbers are really their atomic numbers. They didn't get just assigned, they don't come out of thin air, but they are really equal to the number of positively charged protons that are in the nucleus of the atom of that element. So we order the elements into the periodic table by the number of protons that they have, and notice that the number 1 element is always hydrogen. So again, it's almost like it's interchangeable, the number and the name, and the two always go together. So why do we call it the periodic table? Well, that's because we go this way. So when the number 1 is over here, then the number 2, and then it's like an old-fashioned typewriter. We go ding, and we go back, and we fill it up this way, and then ding, we go back, and we fill it up this way. So we get to go back periodically, and so each of the rows is known as a period, and each of the columns is known as a group. And the groups will have different properties. So members of the same group will sort of behave similarly. The group that you want to look at first is the number 8 group, which is over here, which is at the end of every period. And those are known as the noble or inert gases. And what that means is they don't react, not even with themselves. So a bunch of helium gas is really a bunch of single helium atoms. They don't even react with each other. And the reason they don't react is because they have either full outer shells, meaning full of electrons, or they have 8 electrons in their outer shell. And when atoms have 8 electrons or a full outer shell, whichever comes first, then they are happy just the way they are. And they will not barter electrons for the life of them. So they stay just the way they are. Everybody else in this table is a noble gas wannabe. And so these atoms, when they get around each other, they will try to barter electrons. So they will either try to get rid of electrons, they will try to gain electrons, and if that's not possible, then they will try to share electrons so that they too end up with either a full outer shell or an outer shell, last used shell, that has 8 electrons in it.